My name is Victor Sachs. I'm the Technical Service Manager here at Selig, and today we'll be talking about setting induction heat seal conditions. I'll be demonstrating that using this equipment here. This is an Enercon Super Seal 100. Okay, so first things first is we need to ensure that the head for this unit, which you can see as the tunnel coil, is flat and level to the ground. Path through it has to be parallel to the conveyor belt, and the unit needs to be fixed on the floor, ideally with bolts, and the unit mustn't move. We mustn't be in a situation whereby operators, for example, can kick it and move the unit out of position. Also, it's really important that the control panel on the unit is on the walkway, whereby the operators can see the conditions on the machine and they don't have to cross the filling line to observe it. Okay, as you can see on this unit, we've got plastic guide rails. Quite often I see metal guide rails, and that's a bad idea, simply because the unit itself can heat up the metal guide rails and thus taking power away from the system. One must appreciate that the liners themselves have very small amounts of aluminium in them, and then metal guide rails will be dominating the amount of power that is taken from the machine. I would also suggest a plastic conveyor belt. However, this isn't always necessary, as you'll appreciate. It does depend on the size of the bottle. If you've got a very small bottle, then you probably want to tend towards the plastic conveyor belts. Also, you'll notice on this machine that we have here a center line, and this center line is on both sides of the head. And it is imperative that the bottles pass down that center line so that we know that the power is getting applied evenly to the unit, or to the container as it seals. Okay, so now we're going to talk about measuring the air gap between the underside of the head and the top of the bottle. And it's imperative that you measure that space and not to the top of the cap, because the top of the bottle is where the liner is. So, as you can see, we'll place a full bottle here. This bottle is full because bottle sizes and heights can often change depending on whether they're either full of water or full of the fill product, and whether that fill product is also hot. So we can measure the sample here using the vernier and ensuring that the machine is off, because a metal vernier can heat up in the presence of the field. So we've got a figure here. We know what that height is. These heights typically vary between 8 and 20 millimeters. Obviously, they are dependent on the applications in question. I must also suggest that, once we've established what the height is, then we generate like a plastic spacer to measure that height in the future, so that when the line's being set up, you can use that, because it's quick, simple, and efficient. And also, I advise strongly against using these height calculators that are quite often on the side. Try not to use those because they're not calibrated, and dependent on maybe how the kit has been set up, or if the kit's been moved, then they become totally invalid. Also, measure the height when you're setting up at the beginning of the coil and at the end of the coil. That way you know that the travel underneath the coil is constant. Okay, so once we've collected this data, what we need to do with it is we need to create an SOP, standard operating procedure. And this SOP needs to be accessible to the operators, so that when they change cap and bottle combinations on the line, they can always go back to the same position. If you use the same position every time, then this will maximize the capability of your process. For my next video, we will be looking at the importance of application torque on induction heat sealing.